Welcome to the Wisest King Academy. This is part two of our lesson on compound interest. Today, we are going to be looking at the annual effective or the actual percentage rate. What is the annual effective rate? The annual effective rate is the total interest generated at the end of the year divided by the initial investment. The annual effective rate is usually used to compare investments. So, to somebody or for an investor, if he compares the annual effective rate, he is going to choose the investment with the greater or the highest effective rate. But for somebody who wants to borrow, if he compares the annual effective rate from various sources, he's going to choose the loan with the lowest annual effective rate. The annual effective rate is actually denoted by R, and it's calculated as follows. R is equals to 1 plus IC raised to the power C minus 1. That is the formula. We know IC. IC is the proportional rate, which is I divided by C. C is the number of compounding periods per year. Number of compounding periods per year. So all of this goes just for a year, for a particular year, which is actually the first year. Okay, now let's take a question. We are still going to use, we are using the same question like in the previous video. Please, the link to all of these questions will be in the description section of this video. Please download it and why not solve. Example number 8. Which is the better effective rate of investment? Sorry, which is the better rate of investment and why? Which is the better rate of investment and why? Now, the first one, 12% compounded quarterly and 12.25% compounded annually. The first one, let's take 12% compounded quarterly. So, 12% compounded quarterly, let's remember. Here, 12% is the annual rate, though compounding is done 4 times per year, that's every quarter. So our I here is equals to 0.12, which is 12%. Our C is equals to 4. So we need to calculate our I4, which will be I divided by 4, 0.12 divided by 4, 0.03. So we can now calculate our annual effective rate. Don't forget, annual effective rate in this case, if I customize it, it's going to be 1 plus I4 raised to the power 4 minus 1. So this is going to be equals to 1.03 raised to the power 4 minus 1. So what is going to be R? Let's calculate. So that's 12 point, that's in fact 0.1255. If we multiply by 100, it's going to give us 12.55%. That's the first. So this is saying that this interest calculated 4 times the total interest. If we take the total interest for the first quarter, second quarter, third quarter, fourth quarter, we add up, we have the annual interest. If we take it divided by that initial investment and multiply by 100, it's going to give us 12.5%. Now let's take the second. The second says 12.25% compounded annually. 12.25% compounded annually. So, in this case, what is the annual rate? 0.1225. That's 12.25%. Small c, compounding is done how many times? Only once, right? So we want to calculate I1 is still I, because I divided by 1 is the same thing. So I will be equals to 1 plus I raised to the power 1 minus 1, which will be equals to, let me put the raised to the power 1 so that you see, although it's tautology. So I have 1.1225 minus 1, which will still be equal to 0.1225, which is 12.25%. Remember the question, which is the better rate of investment and why? So the better rate of investment, since this is an investment, we are going to choose the investment with the greater effective annual rate. So the better rate of investment is 12% compounded quarterly. So if you go to the bank and you are told you have two options. Either we give you 12% compounded quarterly, or we give you 12.25% compounded annually. Here, it actually means, although the 12% is the annual rate, interest is calculated 4 times per year. And remember, with compound interest, interest is reinvested, is recapitalized. So, interest increases over time. But this one, since interest is calculated only once, so once you express that annual interest over the initial investment for the first year, you discover that what the real interest rate of that is actually what 12.55%. You can see it's greater than this one. Imagine you invest 1 million. If you invest 1 million, means at the end of 1 year, you're going to have 1,255,000 here. The year you are going to have 1,225,000, a difference of 30,000 francs. So annual effective rate is very, very useful, especially to those who borrow and lend money to or from various sources. So that's annual effective rate. Equivalent rate. Equivalent rate of interest. This is a compound interest. We want to see if two or more rates are equal. In compound interest, two interest rates corresponding to different compounding periods are equal if at the end of 1 year the acquired values are equal. I repeat, in compound interest, two interest rates are equal if their acquired value at the end of 1 year are the same. Now, the equivalent equation, normally, let me put IM. We want to know the IM that is equivalent to a particular IC. The formula is given like this: 1 plus IC raised to the power C divided by M minus 1. This formula can still be given like this for IM equals to the M root of 1 plus IC raised to the power C and all of this minus 1. These two formulas are the same, but this is what I will mostly use. Please, equivalent rate of interest. Two compound interest rates corresponding to different compounding periods are said to be equivalent if at the end of 1 year the acquired values are equal. Unlike the annual effective rate, is the interest of 1 year, the interest expressed as a percentage of the initial investment, that's annual effective rate. But here, we are working on just 1 year. Very, very important. Okay, look at this very well. Look at this. They may say, let me just take the example here directly. We have example 9 and example 10, and I may form another example. Example 9. Calculate the quarterly rate equivalent to a semi-annual rate of 3%. A semi-annual rate of 3%. They do not say 3% compounded semesterly or semi-annually. If it was 3% compounded semi-annually, it means that 3% is the annual rate. So we need to calculate the semester proportional rate. But they have already given what? The semi-annual rate in this case. So here, what is I for? Or let me come. They have given I 2, which is 0.03. We need I 4. What is the quarterly rate? Equivalent to this. So let's use our formula. If we use this formula, we're going to have I 4, which will be equal to 1 plus I 2 raised to the power 2 divided by 4 minus 1. Very, very important. So this is going to be equal to 1.03 raised to the power 2 divided by 4 minus 1. So what is going to be I 4? We are going to use something and test this, right? Let's calculate. 2 divided by 4 is 0.5. So 1.03 raised to the power 0.5 equals to minus 1. That's going to be 0.014889. I could put 0.15. Are we together? It's still the same thing. So this is, please, that is actually 1, 2, 3, 4, 5, 6 decimal places. So this is the annual, this is the quarterly rate proportional or equivalent to a semi-annual rate of 3%. Now, let's say a capital of 1,000, let's say, is invested. Let's calculate the acquired value at the end of 1 year. At the end of 1 year, how many semesters do we have? 2, so it will be 2 periods. So A in that case, if I take I2, which is 0.03, A in that case will be 1,000 times 1.03 raised to the power 2. What are we going to have here? Let's calculate. 1.03 raised to the power 2 times 1,000. You see, it's going to give us 1,060.9. That's acquired value. Let's take the other one. The same. If we use I4, which is 0.0144889, just 14889, it means acquired value will be equal to 1,000 into 1.014889 raised to the power 4, because there are actually 4 quarters in 1 year. So we are going to have 1.014889 raised to the power 4 equals to, wow, times 1,000. And this is going to give us what? 1,060.9 francs CFA, which is actually the same here. So you see, at the end of 1 year, the acquired values are equal. You could also use this formula. You have the same answer. Equivalence of bills under compound interest. In compound interest, 2 bills are said to be equivalent if at a particular date their present values are equal. So like to say that what? P1 is equal to P2. So P1 is equal to A1 into 1 plus I raised to the power minus N1. Take note. To have the present value, we discount the acquired value. P2, that's A2 into 1 plus I raised to the power minus N2. So therefore implies that this P should be equivalent if A1 into 1 plus I raised to the power minus N1 is equal to A2 into 1 plus I raised to the power minus N2. This is the equivalence equation for 2 bills. Now, a single bill may be equivalent to a number of bills. A single bill may be equivalent to a group of bills. For that, the present value of the single bill P must be equivalent to the sum of the present values of the other bills PK. So this equation is given like this: A into 1 plus I raised to the power negative n equals to A1 into 1 plus I raised to the power negative n1 plus A2 into 1 plus I raised to the power negative n2 plus A3 into 1 plus I raised to the power negative n3 plus plus AK into 1 plus I raised to the power negative nk. So this is actually the equivalent equation of a single bill to a group of bills. Two group of bills can be equivalent if the present value, the sum of the present value of the first group is equivalent to the sum of the present value of the second group. But let's come back. In the case of a single bill to a group of bills. Now, this equivalence may be at a common due date or an average due date. At common due date, what they call common maturity to the sum of the nominal value of the other bills. Then at average due date or average maturity, the nominal value of the unique bill is actually the sum of the nominal values of the other bills. So, common maturity or common due date, the nominal value of the single bill is not equal to the sum of the nominal value of the other bills. And average maturity, the nominal value of the unique bill is actually equal to the sum of the nominal value of the other bills. Such question, they will give you a series of bills and you are asked, calculate the average maturity. So because they say average maturity, you already know the nominal value of the unique bill. But if it is common due date, they will give you the nominal value of the unique bill. So we are going to pick up two examples. The first bill is 3 million payable in 4 years, 5 million payable in 6 years, 6 million payable in 7 years. Since they say average maturity, so it means that A will be equal to what? A1 plus A2 plus A3, which will be equal to what? 3 million plus 5 million plus 6 million, which will be equal to 14 million. So the end here we don't know. Okay, we have that. So this will be equal to 14 million. Please, this is example 12. Example 12. 14 million into 1.12 raised to the power minus n. 3 million into 1.12 raised to the power minus 4 plus 5 million into 1.12 raised to the power negative 6 plus 6 million into 1.12 raised to the power negative 7. So we look at this, we are going to have 14 million into 1.12 raised to the power negative n, which will be equal to. Now let's calculate all of this. I will calculate all at the same time. I will just have my answer. So I have 3 million times 1.12 raised to the power negative 4 plus 5 million times 1.12 raised to the power negative 6 plus 6 million into 1 point, sorry, plus 6 million into 1.12 raised to the power negative 7. Okay, equals to. That's going to give us 7,153,805.133. We see that, right? So let's divide both sides by 14 million. We divide both sides by 14 million. We're going to have 1.12 raised to the power negative n equal to So let's take this answer divided by 14 million. That's going to give 0.511. I've taken it to three decimal places. So at this stage, I introduce log. Intro log. If I introduce log, I'm going to have log 1.12 raised to the power negative n equals to log 0.511. Right? Don't forget, log a to the power n is equal to n log a. So I'll bring down negative n log 1.12 equals to log 0.511. So I'll need to divide both sides by log 1.12 log 1.12. So negative n will be equals to, so if I take log of my answer divided by log 1.12 equals to, so I have negative 5.9, negative 5.9. So negative will cancel, which is equals to 6 now. So n is equals to 6 years. So if these bills are to be replaced by this number of bills with the nominal value of the unique bill equals to 14 million, which is the sum of the nominal values for the other bills, it means that all of the bills will be paid in 6 years' time. So this is actually the average maturity. Average maturity is 6 years. Calculate the duration of the unique settlement of 1 million francs to replace the following bills: 200,000 francs paid due in 3 years, 300,000 francs due in 5 years, 100,000 francs due in 2 years. So A is equals to 1 million francs, but N we don't know. A1 is 200,000 francs. A2, 300,000 francs. And A3, 100,000 francs. So the first one is due in 3 years, the second one is due in 5 years, and the third is due in 2 years. The interest rate in this case is 10%, that's 0.1. So this is an equivalence equation, since it is one bill to a group of bills. Now let's replace everything. We are going to have 1 million into 1.1 raised to the power negative n equals to 200,000 into 1.1 raised to the power negative 3 plus 300,000 into 1.1 raised to the power negative 5 plus 100,000 into 1.1 raised to the power negative 2. So this will be 1 million into 1.1 raised to the power negative n equals to, let's calculate this other one, 200,000 times 1.1 raised to the power negative 3 plus 300,000 times 1.1 raised to the power negative 5 plus 100,000 times 1.1 raised to the power negative 2 equals to. So I have 419,183.9852. So I divide both sides by 1 million. Divide both sides by 1 million. So I have 1.1 raised to the power negative n will be equals to, this divided by 2 is 0.41918399852. So the next thing I do, I introduce log. So that's going to give me log 1.1 raised to the power negative n equals to log 0.41918399852. So I divide, but don't forget, log a to the power n is equals to n log a. So we are going to have negative n log 1.1 equals to log 0.4191839852 divided by log 1.1 log 1.1. So negative n will be equal to log of my answer divided by log 1.1. So this is going to be negative 9.12. Negative 9.12. Negative negative cancel. This is approximately 9. So n is equals to 9 years. So it means that the 9 years will be given, the 1 million to replace this 3 years will be paid after 9 years. So that is it. And now we are going to pick up some application exercises. Example number 1, legacy. A man left 24 million francs CFA to be shared among his 3 children. Anake, Bonka, and Job, let's say A, B, and C, and are 14 and 1 quarter years old, 11 and 1 quarter years old, and 6 years old, respectively, the day he died. A. Knowing that each child will only get his share when he is 21 years old, and that the capital inherited is equally shared the day the father died. Calculate the share that each child will receive at 21. Now, note that each share is invested at a compound interest rate of 4% from the date of sharing to the child is till the child is 21 years old. Wow. Now, let the 3 children be A, B, and C. So it means what A will receive plus what B will receive plus what C will receive will equally be 24 million. So the sharing is done today. And the total amount will be what? 24 million francs CFA. And now we are told that as of today, the sharing is equally done. Equal amount received. That's going to be 24 million divided by 3, which will be 8 million francs CFA. So each and every one of them will receive 8 million. Now, but they cannot get in possession of the money. They will only receive the money after or when they are 21 years old. So let's look at the first one. Let's take N. N here will be the duration of the first child. The first child is 14 and 1 quarter years, so we'll get 21 minus 14.25. N2 will be 21 minus 11.25. And N3 will be 21 minus 6. 21 minus 6 is 50 years. 11 minus 21, that's 10. So this will be 9.75 years. And here, 21 minus 14. If I take out 4 from 21, I have 17. That's 7. That's 6.75 years. That's N1, N2, N3. Now these shares are invested at how much? At an interest rate of 4%, that's 0.04. How much would each and every one of them receive at 21? So it means at 21, right? We are going to have the sum. We are going to take what A has received. Now, okay, let A prime, B prime, and C prime be their shares at 21 years respectively. So it means that A prime will be what? The amount that they receive now, we call it A now, which will be equals to, which will be into 1 plus I raised to the power, how many? 6.2, 6.75, that's N1. It's not your time to right? So this will actually be 8 million into 1.04 raised to the power 6.75. We give an amount. B prime will be what B has received now, which is 8 million, into 1 plus I raised to the power n2. So this will be equals to 8 million into 1.04 raised to the power 9.75. And C prime will be C into 1 plus I raised to the power n3. So this is going to be equals to 8 million into 1.04 raised to the power 15. So let's calculate that. 8 million times 1.04 raised to the power 6.7. 10,424,000. 10,424,735.08 This is what the first child received at 21. The second child will receive 10, 8 times 8 million times 1.04 raised to the power 9.75 equals to 11,726,000. 11,726,409.2 francs CFA. This is what the second child received at 21. And the third child, 1.04 raised to the power 15. 1.04 raised to the power 15 equals to times 8 million. 14,407,548.04 francs CFA. Now, this can be justified in that the share of the first child was invested only for 6 and 3/4 years. Meanwhile, that of the second child was invested for 9 and 3/4 years. And that of the last child was invested for 15 years. That's why the amount is bigger. So, this is what they will inherit at the age of 21 if the sharing was done equally when the father died. Now, we go to the B part. Assuming that the sharing is done so that each child receives the same amount when he is 21 years old, after investing at the rate of 4%, share the capital amongst the 3 children today. Now, look at this. That's the B part. Now, let me say this is A, B. Let the share, the equal share, please. Let the equal share at 21 be X. Remember what they will receive today. When they invest it, they will have the same amount at 21. So today, the amount they will receive is A, B, and C, which must give what? 24 million. But now, A received today, when compounded, will give X. B received today, when compounded, will give X. C received today, when compounded, will give X. So what does that mean? Let me put that down. It means that A into 1 plus I raised to the power n1 will be equals to X. B into 1 plus I raised to the power n2 will be equals to X. And C into 1 plus I raised to the power n3 will be equals to X. Now this means that But this implies that if we discount x, n periods will have a. So it means that a here will be equals to x into 1 plus I raised to the power negative n1. Right? B will be equals to x into 1 plus I raised to the power negative n2. And C will be equals to x into 1 plus I raised to the power negative n 3. And remember, if we sum all of those things, which is actually A, B, and C, it must give us 24 million. Let me write this way. So it therefore means that x into 1 plus I raised to the power negative n1 plus x into 1 plus I raised to the power negative n2 plus x into 1 plus I raised to the power negative n3 must give what? 24 million francs. Do we know x? We don't know x. So, but we know x into here. X is common. Can you see that? So we have here x, big bracket open, 1.04 raised to the power negative 6.75 plus 1.04 raised to the power negative 9.75 plus 1.04 raised to the power negative 15. We add all of that. It's going to give us what? 24 million. Let's add this in bracket. 1.04 raised to the power negative 6.75 plus 1.04 raised to the power negative 9.75 plus 1.04 raised to the power negative 15 equals to. So shift 2. So this will actually be 2x, which is equal to 24 million. Wow! Divide both sides by 2. So x is equal to what? 24, sorry, 12 million. So if the sharing is done today and invested, at the age of 21, each and every one of them will receive 12 million. But if this one was asked, no. We're asked for the share of today. How much they receive today? Don't forget that A, or remember, A is equal to x into 1 plus I raised to the power negative n1. So this will be equal to 12 million into 1.04 raised to the power negative 6.75. We have the amount. B will be equal to x into 1 plus I raised to the power negative n2, which will be 12 million into 1.04 raised to the power negative 9.75. We have the amount. And C will be equal to x into 1 plus I raised to the power negative n3, which will be equal to 12 million into 1.04 raised to the power negative 15. So what would that be? Now let's calculate. So 1.04 raised to the power negative 6.75 equals to times 12 million. 9,208,867. 9,208,867.108 francs CFA. That is what the first person will receive. Let's calculate the second. 1.04 raised to the power negative 9.75 equals to times 12 million. 8,186,000. 8,186,649.327 francs CFA. And the last one, 1.04 raised to the power negative 15 times 12 million. 6,663,174.033 francs CFA. Now, don't forget, or remember, we said A plus B plus C will give what? 24 million. So, if we want to confirm our answer, we say plus 8,186,000 and 86,649.327 plus 9,208,867.108 equals to, that is 24 million and something. Why? Because we actually rounded up and round down. So this is the same thing. You see that A plus B plus C is actually 24 million francs. So we share the amount. So that is question number 1. I go to question 4. Question 3. A capital is invested at compound interest rate I for 1 franc CFA for n years. The interest produced are capitalized each year. Knowing that the interest for the 4th year was I for 133,100 francs CFA. And the interest for the 5th year, I5, is equals to 146,410 francs CFA. The total interest generated the n years of investment is, so I is equals to 2,138,428 francs CFA. So that's what we have been given. Calculate the interest rate I, the capital invested, and the duration of the investment N. Now, remember that I4 is A 3 times I, which is still the same as what? P into 1 plus I raised to the power 3 times I. Remember that I5 is A4 times I, which is the same as taking P into 1 plus I raised to the power 4 times I. So the first thing, I told you this, compound interest actually follow a geometric progression. Simple interest actually follow an arithmetic progression. And solving questions in geometric progression, divide. So here, let's take I5 divided by I4. Taking that means we are taking what? P into 1 plus I raised to the power 4 times I divided by P into 1 plus I raised to the power 3 times I. And all of this is going to be equals to 146,410 divided by 133,100. So here, P and P will cancel, I and I will cancel. 3 of these will cancel, 3 here will be left with 1 plus I. So 1 plus I will be equal to, let's take 146,410 divided by 133,100. That's 1.1. 1.1. So I will be equal to 0.1 or 10%. That's I. Now to calculate the amount invested, use either I4 or I5. Let's use I4. If we use I4, remember I4 is equals to P into 1 plus I raised to the power 3 times I. I4 is 133,100 equals to P, which we don't know. 1.1 raised to the power 3 times 1 times 0.1. So this is going to be equal to, so let's take 1.1 raised to the power 3 times 0.1. That's 0.1331. So 133,100 will be equal to 0.1331 P. So we divide both sides by 0.1331, P will be equal to, I'm sure, 1 million. So if I take 133,100 divided by my answer, 1 million francs CFA. 1 million francs CFA. So the last question asks us to calculate the duration of the investment. Remember that given the compound interest, The compound interest, which is P, if I go directly, P into 1 plus r raised to the power n minus 1. Do I know this one? Do I know this one? Do I know this one? No. So that's going to be 2,138,428 equals to 1 million. Big bracket open 1 plus I raised to the power, sorry, 1.1 raised to the power n minus 1. So if I divide both sides by 1 million, divide both sides by 1 million. So I'm going to have 2.138428 equal to 1.1 raised to the power n minus 1. So if this minus 1 comes this way, it becomes what? Plus. So this becomes 3.138428 equals to 1.1 raised to the power of n. When you get to this level like this and you have n is simply log of the other side divided by the log of what n is the power. So this will be log of 3.138428 divided by log 1.1. So n will be how many years? Come on, let's take that. So log 3.138428 divided by log 1.1 equals to 11.99. 11.99, which is equals to 12 years. So n is equals to 12 years. So that is question number 2. Question number 4. A capital C is invested at compound interest during 5 years. Let CK be the acquired value at the end of period K. Knowing that C plus C1 is equals to 125,700 francs and C4 plus C5 is equals to 180,714. Calculate the rate of the investment and the amount invested. Okay, remember we saw, if you go to our video on geometric progression, we had a similar question like this. Now, how do we proceed with such a question? To proceed with such a question, make the first equation to appear in the second equation. How do we do that? Express the first variable or the first item in the second equation with respect to the first item in the first equation, and the first item in the second equation with respect to the second item in the second equation with respect to the second item in the first equation. So we should know this. C4, which is the acquired value at the end of the 4, we C into 1 plus I raised to the power 4. C5, which is the acquired value at the end of period 5, we will express with respect to the acquired value at the end of period 1. It will be into 1 plus I raised to the power 4. This plus this must give this. This principle is true, whether in geometric progression, whether in compound interest, or in amortization of loans. So this plus this must give this. So if we have this, let's write down C4 plus C5. C4 is this, C5 is this. So if I write C into 1 plus I raised to the power 4 plus C1 into 1 plus I raised to the power 4 will be equals to 180,714. But look at C 1 plus I raised to the power 4, 1 plus I raised to the power 4 is 1. So let me bring it up. I open a bracket, so give me C plus C1 equals to 180,714. Do I know C plus C1? Yes. C plus C1 is 125,700. So I have 125,700 into 1 plus I raised to the power 4 equals to 180,714. What do we do? Divide both sides by 125,700. So if I divide, I have 1 plus I raised to the power 4 equals to, let's go, 180,714 divided by 125,700. So that will be I did not divide it by 180,714 divided by 125,700. So that will be 1.437. 1.437 6. Allow you to find decimal places. Now what do we do? Take the fourth root of both sides. Take the fourth root of both sides. If I take the fourth root of both sides, it means I into 1 plus I raised to the power 4 equals to the fourth root of 1.43766. Now this will cancel to have a 1 plus I. I already have this in my calculator, so press 4 or press shift or press raise to the power key or press answer then equal to. You give me 1.095. 1.095. So I will be equal to 0.095, which is equal to 9.5%. So that's what we have there. That's the interest rate. The access to calculate the amount invested. So let's take the first equation. Amount invested, that's C plus C1 equals to 125,700, right? So when I look at this, C1 is actually equals to C into 1 plus I raised to the power. So I have C plus C into 1 plus I, right, equals to 125,700. So this will be C plus 1.1 C equals to 100, sorry, 1.95, 1.095. 125,700. Let's see. So if I add this, I'll have the coefficient attached to C as 1, the coefficient attached is 1.095. So this will be 2.095 C equals to 125,700. Divide both sides. So C will be equal to 125,700 divided by 2.095 equals to 60,000 francs. So the capital invested is 60,000 francs. That's question number 4. Paul Jones deposited 2 million francs in an account for a specific duration. 3 years later, he withdrew 800,000 francs and 600,000 francs 5 years after the deposit. Some years after, he had 4,594,794.679. Calculate the duration of the investment at a compound interest rate of 10% per annum. Okay, this I'm not since it is. Okay, let me just put I. I is equals to 0.1. That's 10% per annum, right? Now, they say Jones deposited 2 million francs in an account for a specific duration. 3 years after, he withdrew 800,000 francs. And 6 years, 600,000 francs, 5 years after the investment, which is actually 2 years after the 800,000 francs, right? Some years after, he had 4,594,794.679. So please permit me to just jump there. His acquired value, the amount in his account, which is 4,594,794.679 will be equals to this 2 million that he put. This 2 million made 3 years, so 1.1 raised to the power 3. And after he came and withdraw how much? 800,000 francs. Look at this. After he withdrew, the balance in the account made 2 years again, 1.1 raised to the power 2. He came down and withdrew how much? 600,000. And now there's another balance that is left for a particular duration. That's 1.1. Let me put it there raised to the power m. Or let me put n. So 2 million was deposited in the account. 3 years after, this is what he acquired. He came and withdrew 800,000. 5 years after the investment, which actually means 2 years after the first withdrawal, he withdrew again 600,000. Now the balance in the account, this is the balance in the account. This should be the balance in the account. Let me chop this. This is the balance in the account. It stayed for a particular period which we don't know. And after when he went, the total amount in the account was 4,594,794.679. Now let's do this calculation. Let me do this calculation. So let me take 2 million. Let me put my 2 million in my calculator. 2 million times 1.1 raised to the power 3 equals to. Then I said minus 800,000 francs. I have that balance. And I said times 1.1 raised to the power 2 equals to. I have then I say minus 600,000 francs equals to. So I'm going to have here 4,594,794.679 equals to 1,653,020 times 1.1 raised to the power n. At this junction, you simply divide both sides by 1,653,020. 1,653,020. If I do that, what am I going to have? So let me take 4,594,794.679 divided by my answer. I have 2.779636,471 equals to 1.1 raised to the power n. So I told you any of the equals to what? Log 2.779636,471 divided by log 1.1. So n will be equals to, so log of my answer divided by log 1.1 equals to, so that will be 10.7. 10.7, which is approximately 11 years. Remember, this is not the duration. This is actually the duration after the last withdrawal, which is 5 years after the amount is invested. So the duration will be 5 plus n, which is equal to 5 plus 11, which is actually equal to 16 years. So thank you very much for watching. Sorry for the long video. It's because of the application exercises I was solving. We have other exercises there. Please, if you want me to solve a particular question, download the question there. Use the link of the Telegram group or the comment in the comment section. Please ask me to solve it, and I'm going to solve, right, and send it to you. Please, you can join the Telegram group by following the link to this video. Thank you very much for watching. Please subscribe to the channel. Share for others to benefit. Thank you very much. God bless you.